Negative 1 quantity squared becomes positive 1 plus 1 is 2. So you end up taking f of 2. And what's f of 2? 3. Okay? So if you got an answer of 3, you're getting the hang of it. But you'll have plenty of more practice with this on your own. Let's get to the bottom part of this and we'll move right on. So at the bottom, we talk about putting in an input-output table. Let's look at setting that up. Same idea. Putting in a domain and getting out a range. With a different type of function here. Those bars around the function, guys, absolute value. So here we go. We're going to put in -2, -1, 0, 1, 2. You can always select your domain however you want. Okay? This is your choice value. Remember another fancy word for input or x values? Domain. So we're going to go right through. Remembering you're going to take the absolute value, yes? So we're going to take the absolute value of -2 plus 3. So you're going to do your work in here. We'll get the coordinate point out here. So I get an answer here of 1. So what's my input-output? -2, 1. I put in -2. I got out 1. Okay? Again, you're taking the absolute value. So here we go. We're going to put in -1, add 3. -1 plus 3. Absolute value, we get 2. Okay? Plug in 0. 0 plus 3. Absolute value stays 3. So we've got a nice set of coordinate ordered pairs. Input, output, domain, range. And as soon as we're ready to finish this, we're going to put them right on our graph, just like you know how. So we finish here. 1 plus 3 and 2 plus 3. Now, depending on your exercises and your independent practice, you may see some different functions, maybe square roots, maybe powers. Different things can happen on a function. Remember, though, you're putting in some numbers, your input values, and you're getting out a variety of values. Stay true to that. Domain, range. Okay? And then when you're ready, we can kind of take a look at the shape of this graph. It's going to be different than anything you've seen before. Values a little more shifted to the left, but we can get a sense of what this thing looks like. You can almost see here, it looks quite like a what? A basic line, right? However, what do you know about absolute value? When you take the absolute value of any number, you always get what? Positive numbers, right? So just for the sake of completion on this one, I'm actually just going to plug in one more value over here. Just going to add it so you guys can see it. I'm going to plug in -4. Again, just getting another input value because I'm actually going to show you guys what the rest of this graph looks like. When you plug in -4, you get the absolute value of -4 plus 3, which is +1. So, again, you'll learn more why next year in the hopes that you guys are all in 512. But the basic shape and look of this graph actually ends up looking like this when you plug in more numbers. Okay? Is the clipboard going around right now, or has it made its way? Oh, Ms. Stewart took it? Okay. All right. So that's an input-output table. Domain, range. Okay? All right, let's flip right on and let's see what else we've got going on here. Get you guys through some more of this. What you're going to notice in some of your practice problems is for you to find domains. Couple rules to go by. In math, you never, ever, ever want to divide by 0. So if there is a number that makes the denominator 0, or if there's a number that will force you to divide by 0, you can't have it. Another thing. You can never take the square root of a negative number, okay? So I want you to remember those little rules as we look at number 1. This is a function, f of x. It's a ratio here of 1 over x minus 2. Look at the denominator. You can never, ever, ever divide by 0. So ask yourself this, what value of x would make this denominator 0? 2. So x minus 2 cannot equal 0. X cannot equal 2. You guys have to be ready to do what's called domain restrictions, telling me what x cannot be. Look at the next one. You can never, ever, ever have the square root of a negative number. So this value in here, x plus 3, must always be positive. Set up a little inequality. X plus 3 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to, right, if you subtract it over. So only values of negative 3 would work. Think about it. Could you have negative 4? What's negative 4 plus 3? Negative 1, not good. Anything after negative 3 is just fine. Look at this last one. Denominator can never be 0. And radicals must always have positives inside of them. So this one's like 2 for the price of 1. X plus 3 has to be greater than 0, but not equal to, huh? How come this cannot equal 0? Because it's in the denominator, okay? So that's another one. Look at this fine little difference between these two problems. This one, you could have negative 3. This one, you can't. Okay? So those are little things with domain restrictions. Again, more independent practice.